Okay, today I thought I'd do a little demo of what I have so far for a project I'm calling B-LISP, which is implementing a very traditional Lisp in Blitzmax, mostly because it's kind of a non-traditional language to do such a thing, and I don't know, it's just kind of a fun challenge. So basically, the first thing we can do, I've got Emacs up, by the way. The first thing I can do is open up a terminal in Emacs, just to get it up, and we'll go bin bash and make sure we're in B-Lisp. It looks good. I've compiled it to B REPL, REPL being read, evaluate, print, loop, traditional way Lisp interacts with programs. And I thought I'd just demonstrate some of the very, very primitive stuff I have in here. Right now it doesn't have any looping, it works via recursion, but eventually when I get the optimization in for tail calls, those will be eliminated and you'll be able to do true looping. Right now you can only mutate symbols. You can't symbols that are you can only mutate values that are not collections because the garbage collector isn't in. There's a very primitive garbage collector, and it just basically reverts back to the symbol table, but it builds everything on the stack as you recur. So in that regard, it marks the basis of where the data starts, and you go off and you do all this stuff, and then all that stuff gets basically blown away. It's a very, very primitive garbage collector set to a fixed number of bytes. I guess I could start. Let me just open one of the files here. Let's go into, let's see, B-Lisp is probably a good place to start. So I'm actually using NAN boxing, which is basically abusing the double floating point system such that you can mark some of the bits to show that a value is not a number. That's kind of why NAN is there. You can have numbers that aren't numbers, but you can kind of store that as a code meaning something else. Lisp only has a handful of primitives, and we use that to encode them. If I scroll down here a little bit, I guess most Emacs guys are just page down, but I'll scroll so it doesn't look so jarring. We'll go down to the function table, and there's more than one file. This just happens to be the main one. But these are kind of the functions that I've encoded in this, and each one has a pointer to another function that it calls. And this is actually based on Tiny Lisp, which is Lisp in 99 lines of C. It was made for basically an 8-bit calculator. I forget the name. It was either, I want to say Casio, but I might have the wrong number. But basically, you implement a programming language in C, and instead of that, I'm doing it in Blitzmax because it's kind of a non-traditional environment. So I guess I have some information at the top. This here is the Tiny Lisp repository, and you can go take a look at that. I've deviated from that a little bit in that I've renamed some of the functions to be a little more traditional. As far as some of his stuff was a little bit overly simple, so I went back and implemented some more complex features. But the main thing on the horizon is getting this fixed up. I want to get it into a more OOP model so that the Lisp machine is bound, all of its memory and everything else, and you can have multiple instances at once. That would be ideal. But anyway, I've yammered enough. So what I'm going to do is I'm going to go ahead and start the program here. I'll start the REPL. And okay, you get this traditional, REPL. One of the nice things about Lisp is they don't use that operator crap. Basically, everything's a function, so you can do things like this. Since everything's a Lisp, or everything's a list consisting of a symbol that names a function and then the parameters, you can do something like this, and you're not typing out, 4 or 5 operators. And of course, you're going to get 15 back. And of course, you can do such a thing like this. And not all operations are encoding this way, but most of your math ones are. You'll notice that all of these come out in floating point, and that's because we're going back to our NAN boxing and our special encoding. So numbers right now are universally doubles. If you want to have specifically an integer where you'd interact with the underlying BlitzMax framework, then what you have to do is you'd have to have a function to cast that. I don't have it there yet. This thing is very much in its infancy. So for now, let's go ahead and start a graphics session. I've wrapped some of the routines that you'll see in BlitzMax. So graphics 800 and 600. In Lisp, we don't waste time with commas. I mean, a comma and space is redundant, so space works just as well, and it's visually the same. So we'll go ahead and call a graphics screen. And I've got it pop up on my other screen here, but here it is. I'm going to right-click this and make it always on top here. I think there is a keep above others. Yes, so that'll let us type and work down below it. It helps if I can get down to the REPL. But we'll be working below this, and it'll stay on top. So first of all, let's go ahead and clear the screen. CLS. I've wrapped that too. You'll see a lot of garbage print out. This is my own debugging stuff and internal representations as I debug, because there's probably bugs in this. I've implemented the base case of I think, what is it, Mr. Van Winkle, or let me get his name right, Van Engelen. I guess I've got Robert's base case basically implemented. So I'm printing debug stuff, and next I'll have to test this stuff. You shouldn't be using this yet. It's way too early, but I just want to prove kind of how the REPL works right now. So I'm going to go ahead and I'm going to go to this part of, these are just some Lisp functions that I wrote out beforehand. And of course, this is defun is basically, makes a new function. And this I've just called random 255. It's just convention to use the minus sign to split up your words in functions. That's not, remember, we don't have operators, so that's not going to do anything in infix like that. But this basically takes a function called random, which returns a number between 0 and 1. It's exclusive on the 1, and it multiplies it right here by 255. I can show you here. It's a live system, just so you get an idea. You'd get this number back here. Okay, so the idea is we're going to make a random 255 value. We've kind of abstracted that because it's something we're going to use a lot. So down here there's a random color function. Of course, I've wrapped the BlitzMax set color function, and I can call that. And we're just going to assign that 3 new random 255 values. Okay, and then that should be pretty self-evident. If I call random color, it would generate a random color. So then we've got down a little more complex function called draw squares, and the idea of this is it's just going to draw n many squares. I'm assuming 64 width pixels just for the demo. You could put you could put your parameters in there and then replace those, and it's going to draw them 32 pixels apart and just cascade all the way down. So cond is kind of like your case statement, and the way cond works is it has a list of. Let me highlight this a little better. So if I come in, it has this series of clauses, and the first part of each of the clauses is your test. And if that test passed, then it calls the functions below it. Now, earlier I mentioned that I didn't have loops implemented yet, and only recursion, and unsafe recursion at that. So using the limited features that I have implemented right now, it will call itself at the end only. Well, let me back up. Basically, it's going to say, hey, n needs to be greater than 0. Okay, n is what we're passing in. That would be your 10 times, your 13 times, that kind of thing. And as long as that's greater than 0, it's going to set a random color, and then it's going to draw a rectangle. Of course, we're taking our 4 parameters. Everything's positional, so we've got 4 parameters. And of course, following the Lisp evaluation rule, the first thing it's going to do is look to the first symbol. And if that's a function, it's going to call it with the parameters. Okay, so we're just going to calculate n. We're going to move it over by 32 each time, and it's a 64 by 64 square. And then, because n was greater, not yet 0, we're going to call itself again, and we're subtracting 1 from n. And it's just going to keep going and looping and looping and looping and going through recursion. And by the end of this, we'll have our n many squares drawn in random colors. Okay, so here's kind of a problem right now. We currently can't just paste this in as is, because new line is the it's kind of the end of the line character, and it would cause this to be hammered into B-LISP, and right now B-LISP is not advanced enough to handle multiple lines. So we are going to have to make this critter here a single line deal, which is not too hard in Emacs. So what I'm going to do is I'm going to tell it replace all new line characters, as many as there are in a row, with a space character. Okay, you can see query replace, and actually I think I've already got it. Yeah, I've already got it implemented. So I'll just hit return. Now it's going to mark those, and if I hit shift and exclamation point, I'm going to back up, we'll get that. Okay, I'm going to copy this, and then I'm going to come over here, and I'm going to terminal, and I think line mode is what I want, because there's different modes in this that's kind of obnoxious, but I can paste this in now, and hopefully, okay, we'll see that we got the name of a function back. So this function has been interned. Okay, so we'll mark, go to the beginning, we'll execute our replacement deal, and then we will go here, I'll go back, I'll go to the beginning, I'll copy that again, I'll come over here, I'll yank it back in, let's move our window down, okay, get this back in focus, okay, and it says random color. Okay, so we've got a random color here, well, a function for one. Okay, and we'll come back here, mark it, we'll go to the beginning, run our, why am I saying R? Am I in elementary school where I have to include the whole class? Run my function here. Okay, we'll hit enter there, and I will just hold shift and exclamation point. I will go to the end of the function, mark it, go to the beginning, copy, go over, yank this in. I always want to see what's being entered in case there's a problem, and I will hit space there, and now we've got draw squares. Okay, so what I can do, did I CLS this earlier? I gotta look back and remember here what I did. Did I CLS? I wonder if I double CLS if it'll cause any issues. We'll do this. Okay. Alright, so now I'm going to call draw squares. Wait, is that what it's called? I got to double check. Draw squares. Okay. And we're going to do 13. And we'll see that nothing appeared, right? Well, this is Blitzmax. We need to flip it. And of course, they appear. We've gone through all of our functions. I've inserted functions in real time. I've added functions to this running Blitzmax system, and we've taken what was Blitzmax and we've elevated it into a language that now is a real programming language on top of Blitzmax. It's very slow right now. Eventually, I'd like to get it compiled, and I can do such a thing. It just takes some reading and study. But eventually, I've elevated this into a live system from something that was reasonably static, with a full programming language underneath it. And there's a lot more functions, and there's a lot more things you can do. The language is very small, but it's going to grow. I'm going to keep wrapping sprite drawing functions and everything else, but this is very much the style of Lisp in that you work in an interactive way with it. Right now, B-Lisp is not healthy enough that it won't crash if you put something bad in, so I would say hold off on this, downloading it or whatever. I've got a long road ahead of me, but this is just like the skeleton right now that's still, reasonably feasible. So anyway, yeah, just kind of a cool thing. I've got an interactive REPL built in Blitz, but what I had to do, just to remind you, what I had to do is I had to completely rebuild and redesign the type system to be dynamic. And actually in Lisp, it's what you want, because these lists can be anything, right? This kind of thing, and I don't have strings in yet. So we're going to get a Lisp of hello, or a list, hello 21, and like 40. This would be hard in another language because, static programming languages make this a mess, and it's a pain in the butt. Lisp is basically designed to write algorithms in. So, you get a list back, right? You get a symbol and all this jazz. So anyway, more powerful, flexible language on top of a rigid one, interactive, dynamic REPL. Anyway, I think that's all I have to say, so have a good evening, and we'll catch you later.